going back to counting numbers here, maybe I should have done this with those, but how many three-digit numbers have the sum of their digits equal to 5? How many three-digit numbers have the sum of their digits equal to 5? Well, again, we're talking three-digit numbers, and so really the only restriction there is the first number can't be 0. So give me one example of a three-digit number that has the sum of the digits equal to 5. How about, I'll give you one, 221. Wouldn't that work? 221? Wouldn't that have the sum of the digits equal to 5? 2 plus 2 plus 1 is 5. Okay? Now, what I like to do is once I get that one, rearrange those, just those very same three digits, because if I just rearrange them to be 122, wouldn't that still be a sum of 5, but that would be a different three-digit number? I could also arrange it to be 212, same three digits, but different order, and that's another three-digit number. So there's three-digit numbers right there whose sum is 5. So that's the way I like to do it, just come up with one and then cycle through all those. All right, but there's other ways I could do 311. 311 would have sum of 5, wouldn't it? 3 plus 1 plus 1 is 5. Okay, so what else could I make with it? 131 or 113? 3 at the end. Okay, how about 140? Isn't that 5? Okay, so I could do 104. Or I could do 401, or I could do 410. Or I could do, how about 500? Okay. What else? There's one other group, I think. Think of it. 320 would be 5, wouldn't it? So I could do 302, I could do 203, or I could do 230 out of those. How many is that? 3, 6, 10, 15. Think of any others? I think that's it. 15. 15 total. Okay, so that's just kind of a system. Just kind of cycle through all the different variations there. What you want to come up with. All right. Now, this last one here on the listing, probably might have seen a problem similar to this before. But let's say I've got a triangle. And then there's some lines on the inside of this triangle like this. Crisscross, kind of like that, and then one straight across there. Okay. We've seen this before. How many triangles of any size are there? How many triangles? Any size triangles. Well, of course, you got the big triangle. You got the little triangles. But the thing is, you've got triangles made up of various parts, like here. This one kind of there. All right, so that's a different size triangle. So you can make triangles of more than one at a time, you see. Here's the way I like to do the system. If I number these off, kind of like we did the Venn diagrams, 5 pieces. So yeah, of course I've got the triangle number 1, 2, oh, and be sure each one of those is triangles. Sometimes they're tricky and each part is not necessarily a triangle, but I think all 5 of those are triangles. So I've got those 5, but then I've got, like the one I pointed out, 1, 2, 3 is a triangle. Well, let's do this first, before I do that one. Let's put 2 of them at the same time together. 2 of them at a time. Do you see one that have 2 at a time? That'd be a triangle. How about 2, 3? 2, 3 would be a nice little triangle. 2, 5 is a nice little triangle. And 4, 5, and 3, 4, all those are triangles. See what I'm saying? Now, I didn't put 1, 2 because 1, 2 is not a triangle. That's what I'm saying. Be sure you're listing triangles here. But you see where I'm going with this. Now let's do the 1, 2, 3. It's a triangle. 1, 2, 5 is a triangle. See any more with three of them at a time, 3 parts? I don't think so. I think that's about it. And then, of course, the big triangle, all 5 parts together. I think that's about it. That gives me a way of keeping up with what I've counted. You know, I've counted the small triangles. I've counted them where they had 2 at a time. I've counted. So yeah, I think I've got it.